To find the domain of any logarithmic function, all we need to remember is that the argument of the logarithmic function must be positive. So, if we want to find the domain of f of x equals log base 2 of x squared, we need to understand that the argument x squared must be positive. Well, if we think about the graph of y equals x squared, we recognize that it's everywhere positive except at the origin. Therefore, x squared greater than 0 is true provided x does not equal 0. So the domain of this logarithmic function is a set of all real numbers x such that x does not equal 0. Remember, to find the domain of a logarithmic function, all we need is for the argument of the logarithmic function to be positive. So, for this logarithmic function, we need x plus 1 over x to be positive. Well, let's think about how that can be. All we need to do is solve this rational inequality. To do that, we identify the zeros of the numerator and the zeros of the denominator and use those zeros to create an interval of numbers. The zero of the numerator is -1 and the zero of the denominator is 0. So we're going to look for all x less than -1 as one of our intervals, all x between 0 and 1 is a second interval, and all x greater than 0 as a third interval. Now, rather than using test points, we can use pure logic here. If x is less than -1, then the numerator is going to be negative. The denominator will also be negative, so we'd have a negative divided by a negative, which is a positive value. If x is between -1 and 0, the numerator is going to be positive, the denominator will be negative. Positive over negative is a negative value. If x is greater than 0, the numerator will be positive, the denominator will also be positive. Positive over positive is a positive value. We want to know where this entire expression is positive. That's for x less than -1 or for x greater than 0. So the domain is the set of all real numbers x such that x is less than -1 or x is greater than 0. Or if you want to use interval notation, the domain is the set of all x such that x is less than -1 or x is greater than 0.